This video is on traversals of binary search trees. An advantage of arrays and linked lists is that they're easy to traverse. In other words, we can systematically visit, for example, we could list the values in order. So how can we systematically visit all of the values in a binary tree? We're going to consider three different algorithms for doing so, inorder, preorder, and postorder. So let's look at inorder binary tree traversal, binary search tree traversal. This visits the nodes in order from values least to greatest. So in this binary search tree, we would visit node 1, then 3, then 4, 6, 7, 8, 10, 13, 14. And so let's see an algorithm for doing that recursively. We are going to start at the root and visit values in the left child until there are no more left children to visit. So we start at 8 and look down at left child, look down at left child. Now we're visiting this value in the left child because there were no more left children to consider. Then we visit its root, the root value. Then we visit the values in the right child, so we're visiting the right child. If it has any left children, we're visiting its left child, then its root, then right child, and so on. So the first level of recursion creates this set of nodes, or these set of values, 1, 3, 4, 6, 7. We see everything in the left subtree. Then we see the root 8, and then we see everything in the right subtree in order. So here is the pseudocode for inorder traversal. In inorder traversal, each node is visited between its children being visited. So it's visited after its left children and before its right children. So here is our pseudocode on the right. Again, this is going through this different binary search tree, starting at the value 60, then going straight down, passing through 25, going to 10. We are running out of left children, so we are now visiting the node 10 and going back to the root and visiting that root. Now that we have visited the root, we are visiting we are going towards its its right children. So we're going to the right child. If it has a left child, we're going to go down to it. It does. We're now visiting that left child, going back to the root and visiting the root, going down to its right child. If it had any left children, we would go there, but it does not. So we visit that node and go back to the root. We've already visited it. Go back to the root of this. We've already visited it. Go up to its root, 60. It hadn't been visited yet, so we're now visiting it, and so on. And so the inorder traversal is going to visit the nodes in this order, from least value to greatest value. Okay, so let's think about the stack that occurs during this recursion. So when inorder is called, at various points, there are actually multiple copies of this code being run. So, for example, at this moment, when we're looking at this node with containing the value 30, we would, at that point, we had started running on the root 60, and then as we were running on the root 60, we're considering the node which contains 25. We are then considering the node that contains 35. We're then considering the node that contains 30, and all of those are running at once. They're just sort of paused and running. And so one thing we want to sort of minimize is the depth of the execution stack. So the number of different copies of the program that are running at any one moment. For inorder traversal, the maximum depth of the execution stack will be the height of the tree plus 1, and as we know, the height of the tree is approximately log base 2 of n, where n is the number of nodes or values in the tree. So to understand that a little bit better, let's just see this with an example and the actual step-by-steps of what's running at various points. So if we're starting and running on the node that contains the value 60, then we're currently at line 0 of this pseudocode, and then it's telling us to look at the left children. So we're looking at left child. We're now looking at its left child, looking at its left child again. We are now at line 1 of this third copy of the code, and it has no more left children, so we're actually going to visit the value. So we're visiting that value, and this is the first time that a value is actually recorded. We've so far just passed through 60, passed through 25, and now we're visiting 10. Then we finish this implementation of this copy of the code, and so now we are going back to the previous copy where we're running on 25. We have finished line 1, and so now we're going to visit the value 25. We're actually executing line 2, and after we've executed that, we're going to look at its right children. So we're now executing line 3, and we are visiting we are not visiting yet. We are now running a new copy on the node 35. We are now going to its left children. We're on line 1. Now we're on 30 on line. Now we're on the node 30. So we are opening up a new copy of this little code, this recursive code, and now we are going to run that on node 30. It has no left children, so we are going to visit the node 30, and we're going to look at its right children. It has none, and so we are going to go back and continue running on the node 35. We have looked at its left children, so now we're going to visit the node 35, and actually we've now recorded the value 35 or listed it, and so now we can look at its right children, and now we are running on the node 45. So that is what is happening in this algorithm, how we are recursively running this program, running copies of this program at this depth, and that would continue on the right side of our binary search tree. Okay, so that was in-order traversal, and as we said, it visits the nodes in order from least to greatest. Okay, what's another algorithm we could have to traverse a binary search tree? We could look at the preorder traversal. So here, each node is visited before its children are visited. So here is our pseudocode for doing that. We visit the node, then we look at the left, and we visit them, and then continue on the left until we're done visiting and start to look at the right. So how does this, in what order does this visit these nodes? It visits 60, and then 25, then 10, then it's then 25's right children, so 35, then 30, then 45, and then we've already visited 60, so we're looking at its, and we visited all of its left children, so we're looking at its right child. Now, after visiting 90, we're looking at its left children, and so on. So this is, as we said, the order in which the nodes will be visited for preorder traversal. So each node is visited before its children are visited. And then if we look at postorder traversal, this is when each node is visited after its children are visited. Here we would start by basically at the bottom of the search tree, and we're visiting our nodes in the following order. So we start at the root 60, but we are not actually visiting the value at 60 yet. We are just going down as far as we can on the left, and we are visiting the node 10. So we have visited that. We pass through 25. We have not visited it yet. We pass through 35, and then we visit the node 30. Then we pass through 35 again and visit the node 45. So we can see we visited all of the children. And because we visited all of 35's children, we can now actually visit 35. Now we have visited all of 25's children, so now we can visit 25. And now we're going to pass through 60 because we haven't yet visited all of its children. And so we can now pass through 75. We haven't visited all of its children. We're going to now visit 65, and then we would pass through 75 again, visit 80, then we can visit 75, and so on. So this is the order that the nodes would be traversed using Postorder Traversal. So here's just a little diagram of the 3 binary tree traversals, 3 binary search tree traversals visualized for the same binary tree. In Inorder, the first one we looked at, we are traversing them in the order that gives the values from smallest to largest in order. In preorder, the second one we looked at, we are visiting the parents before we visit their children. So that is the order in which we would traverse the nodes. And in post order, we are visiting the children before we visit each of the parents. So we're visiting all the node's children before we visit the node itself. So each traversal has a distinct application or generalization to graph traversal. Inorder obviously has the advantage of traversing the nodes in order of their values from least to greatest. Preorder will be generalized by a breadth-first search. So we sort of stop and look at all of the parent values first, or we see parent values before we go deeper, before we look at their children. Whereas post-order will be generalized by depth-first search. So we go down as far as we can and we explore something all the way down before we start going back and exploring up at the top.